welcome to the session. Welcome to the technical part of the session, where we're going to cover containers that mostly hosted on Kubernetes. So here we're going to cover how attackers can potentially compromise containers, but also what I also found when I work with cybersecurity professionals, that they may not have a full understanding of the container infrastructure. So in the beginning, I would like to give you like an idea about containers, what they are, and how all those services work together. And then we're going to take a look at possible security issues, and of course, I'm going to show you many live demos. How some of the issues can be exploited. Used in a live demo. And in the end, we're going to discuss protection. What can we do to protect our environment on Docker and Kubernetes? All right, so a couple of words about me. My name is Sergey. I'm a consultant, instructor, speaker at conferences. I'm also EC Council mainly certified, like CEH, Master. Just the name Master is too long, so that's why I didn't add it here. CPENT, LPT, CCSE, which is Cloud Security Engineer, Instructor, and so forth. And I'm going to present for you this webinar. So, in the beginning, let me spend a few minutes just to explain you what containers are and what does it mean, Docker, Kubernetes, how do they work together? Because again, before you protect something or compromise something, you need to know what it is. And again, since that's some kind of like DevOps technology, not everyone in security may full understanding of containers. So I would like to give you like a general idea. So containers are lightweight, portable, and self-sufficient environment that we use to run applications. And so, in fact, container become like a package that contain everything: application, all the dependencies, libraries, components that need to be used for this application. So it's like that's the keyword, self-sufficient, that contains all dependencies. Also, because of the containers share the code with host operating system, share the kernel, they are smaller, work faster, deployed faster, so become more efficient. So compared to virtual machines that like has full operating system, and which is much larger, much slower, takes long time to takes longer to move between hosts, containers are much faster. So that's containers. Then you heard words Docker and Kubernetes. So what they are, what's the difference between them, and do they work somehow together? So Docker is the platform that will enable developers to create, deploy, and run applications in containers. So most of the time we use Docker nowadays to create container images, so to create the actual application. It can be done manually, but of course most of the time it will be done using pipeline automatically. So not really, it doesn't mean that developer every time build a container manually. And so in Docker, you can also run containers. So in fact, you can run application, but it may be okay to run it for small business or like for dev and test purposes. But when you would like to do it for the large company, when you have like hundreds of containers and you would like to properly manage those containers, scalability, availability, resources, storage, and memory, and so forth, with Docker, it become kind of a big challenge. So here we use for like most of the time, most companies use Kubernetes as the container orchestration tool. So in that case, it helps manage scale multiple containers efficiently, automate deployment, balance the load, have the replicas of containers, monitoring, and so forth. So that's the Docker and Kubernetes. So usually they work together because we build containers using Docker, but we run them in the Kubernetes because we would like to not just to run container, but we would like to run them. We make it scalable. We would like to run hundreds of containers, not just a single container, and so forth. When we build containers, we need to build container from image. So compared to virtual machines that can be installed from like a ISO, where you can just click next, 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 I would like to choose this time zone, this language, and so forth. In containers, we don't do it. In containers, we always build from images. So image is the actual package that we're going to use to build container from. And images must be stored in container registry. So container registry is the repository where container images are stored. So stored, shared, and managed. So for example, if you would like to somehow deploy container in Kubernetes, Kubernetes must have access to the image, and image will be stored in container registry. So as the result, Kubernetes will take image from container registry. So I have a slide for I have a slide for this. So let's take a look at the first full process. Developer packages to image the application, and again, they don't do it manually most of the time. It happens automatically using pipe. So when they commit the code, so the pipeline, they pick it up. Then image is stored in a registry for ease of access. When you would like to deploy application, Kubernetes pulls image from a registry and deploys the container in Kubernetes. All the rest is like optional. Let's say if in Kubernetes we have a lot of traffic, it may scale, and so the application by running more containers. And if there's a newer version released, Kubernetes update containers seamlessly and minimizing downtime. So as you can see, there are several services that involved into the process. So first of all, Docker, where we build the container images, then the actual registry where we store our images, and Kubernetes where we run those containers. Of course, on every of those steps, on every stages, there are number of problems. There are a number of possible problems. So now let's move to security part. I hope that previous slides were clear enough just to give you an idea about what those services are. Let's take a look at the possible problems and attacks on Kubernetes, but not only on Kubernetes themselves, but also on this process I described before. So let's take a look. First, harvesting credentials. So malicious actors attempt to locate and extract sensitive authentication details. So it might be sometimes even the most obvious attack, and I will show you that soon. Then improper permission settings. So overly permissive configurations that can create security gaps. For example, if someone has access to container registry or the workstation where we have some kind of saved configurations, then it may cause a number of problems. Again, I will show you that. One more, compromising supply chain. We also have webinar last year in December, I remember that, about supply chain attacks. Is that somewhere between the supplier and the consumer and the company that used the product, something may be inserted, something malicious can be added. So, and if, for example, company deploys containers from unverified, not trusted repositories from registries, or maybe someone had if registry had improper permission settings, and someone could insert some malicious code into the repository, then it can lead to compromise of container. And as the result, if we don't have like good network controls, one compromised container can lead to compromise of other containers, because you probably heard of lateral movement. So attacker from one container can try to jump to another container and so forth. One more thing that also could be a problem, that companies may expose some components like API server, like a master node, and available from outside, which can be like attackers can attempt to attack. So that's some of the possible problems, and I would like to show you live demos how they can be how it can look like in the real world. Let me move to demo environment. So here I have a couple of machines. One machine for Kubernetes administrator. So this one is like a legit administrator. I have a wallpaper for that. That's the legit admin. Then second machine will be attacker that going to do some naughty things. And finally, my registry. Honestly, I don't really need to connect here. Just want to show you that here I have a registry where I'm going to store my images. Also, you cannot see those machines, but I have master node of Kubernetes and worker node. First of all, I would like to show you the most typical, the most simple attack that will take me like just a couple of seconds. Is just to get configurations from one machine to another if those config files weren't protected properly. So let's take a look. If I open admin machine, there is a quite typical tool for administration called kubectl. Let's say kubectl get nodes. If you ever work with Kubernetes, you know what I'm doing. So I'm just showing what kind of nodes I have. So I have master node. That's my Kubernetes master node. And I have a worker node where I'm going to deploy my actual pods or containers, if you want, applications. So as you can see, I didn't provide any credentials. So I did not provide username, password, and so forth. I just typed the command and it showed me the result. If I take a look at the available pods, so let's say get pods, it showed me my pods on that Kubernetes cluster. So somehow it works, right? My commands, they work without additional authentication. It happens because I have config file, and in Windows, this config file available here in the folder called .kube. In Linux is the same. I mean, not the same, but that also the same config file. But you choose yourself where you would like to place it. Usually, it placed in the administrator profile. So here's the .kube, and I have config file. So what may be a problem? If someone else has admin rights on the machine, maybe help desk or service accounts, and this service account is controlled by someone, then what I can do, I can use using SMB protocol, I can copy this folder from one machine to another, and it will give me the same level of privileges. So for example, let me open attacker machine. Go to kubectl. Let's try to get nodes here. And it says no, unhandled error, there's no connection, there's nothing here on localhost and so forth. Let me clear the screen. And now I would like to copy this one from one machine to another. To here. Oh, I can just copy the whole folder. There's no .kube. Okay, it wasn't that bad. All right, so let's try again. Yep, now it works. So, and if I type get pods, I can see the same. So first of all, that easy. I can't even call it hack. It's just the easy trick, but in pen test, that's one of the things that we usually try to find some easy quick hits and some low-hanging fruits. So first of all, you need to take a look at the admin tools, and make sure that your credentials are well protected. But let's take a look at something more complicated. So before that, so you saw on the slide about improper permissions, compromising supply chain, inadequate network controls, and so forth. Let's try to combine all those things together and try to add some kind of malicious code into the container image, and then push this image back to registry. And after that, compromise the other containers on that Kubernetes. I will work here from the attacker machine this time. And what I would like to do, oh, by the way, because we have limited time, I already pre-configured a number of things. So I will not show you the full, all the steps in live, because otherwise it will just take too long. I already pre-configured a number of things. I will show you how to do them, but they already pre-configured. So if I have them like container registry. And container registry, my default container registry that I'm using from Docker does not require any authentication. So if I have physical access to this container registry, I mean, if I have network access, if I can access this registry by using network by the network, I can pull and push images to this and to this container registry. So, for example, if I would like to pull some kind of images from the registry, I can easily do it. I can type something like this, Docker pull, and then specify my container, like the name of the image in container registry. So my container registry name is K8s registry. It uses port 5000, and the image is hello W. So if I do this, it will download the image from a registry. Again, you may configure authentication, so that may be a bit more complicated. In that case, attacker needs to have access to must have credentials. In my case, I just took it as is from Docker Hub and did not configure any authentication. And so what I can do next, I can say I would like to save it as a file. So I can say Docker save, and then say that this one needs to be saved output. I need to make an output as like a, let's say, image from registry.tar or any other extension. So I can do this, and it will download image as the file. So I did it before because it takes some time before, like the pull, it takes time. It might take like minute or so, and since it's like I'm trying to save time, I already pre-configured. So here's the original image, almost original image I download from registry. So what I can do, I can open 7-zip, and I can see here that this image is nothing else than like a tar archive. And if I extract it, I can probably make some changes. So let me extract to like a folder. I'm going to rename the folder to something like ECC. And so, by the way, structure may look slightly different. I also have like a newer format, just in case if you try to do it yourself and you see different structure, you may see it's something like this, which is pretty much the same, just looks slightly different, but the process will be the same. So after I extract the container image, I can open different folders. For example, let's take this folder, and I can see here layer tar. Everywhere I can see layer tar, which contain all the components for this application. So it might be dependencies, it might be libraries, it might be the actual application. So in this layer tar, I think it contains, that contains the HTML page of the application. If I look at the different layers, it contains also some libraries, so dependencies and so forth. What I can do now, let me take the smallest one, which is the HTML page, extract it. Now I have the folder. What I can do, I can place my own files there. I can place my own files, and here I have a file with additional library, which will be my reverse shell. You know, you are in ethical hacking, you know what a reverse shell is, so I think I don't need to explain it. So I would like to place my library, my shared object, into this container image. So I'm going to place it here, and I would like to zip it again. When I say zip, I mean tart. with 7-zip in the tar format. Okay, so now we have the layer the tar, and this time this layer with added shared library. Let's check it. Yes, so shared library is here. One more thing I need to do before I move to the next step. I need to check the file hash. So let me go to ECC and C6 something. So I need to get file hash of the previous layer, the tar. All right, and now if I need to replace it, I would like to make sure that I know the new file hash as well. So, and the last step I need to do, I need to go here into the the home page of the container image. Oh, great. And I need to make some changes. So first of all, I need to run my shared object. Yeah, I know it's a lot of text, but here I added my own commands. So I preload my shared object, and I give also attributes. So remote address, that for my command control center will be this IP address, and the remote port will be 4444. Like quite typical for the demonstration. Last step I need to do, I need to change the hash of the layer, the old one, to the new one. So we can see here E24 something something. That's what we found before, right? Yes, E24 something something. So I need to replace it with my new hash. The only thing that must be in the lowercase, because you can see it's in the lowercase. So let me change it to lowercase real quick. And let me change that to here. All right, so I can save it and zip again. So as you can see here, that's a quite simple way to do this supply chain attack. Again, of course, we not yet finished the process, but we just trojanized the image that used to be legit, but now this image contains some kind of Trojan, which potentially can do some damage. So now let me place it back to my oh, probably I did not remove the folder. Yeah, I did not remove this folder. It's not critical, but let's do it just in case. Let's do it again. Archive. And replaced. All right, so now I have ECC.tar, which is Trojanized image with some kind of application. What might be the next step? Next step is I need somehow to distribute this ECC.tar into the registry. But first, I would like to check if this Trojan is really working. To be fair, it takes a bit of long time to load it into my Docker. So what I need to do, let me show you what I need to do. Let me go back. So I need to type docker load -i and specify the ECC.tar. But it will take maybe a few minutes even to load into Docker. That's why I already did it, and I already have it. I already have images in my Docker. So I load into my Docker. I load the image into my Docker. That's what I did. That was my loaded image. Then I need to also mark it properly. Oh, probably that's the one original. K8s registry 5000. That was my original image. It's a Trojanized image. Now what I would like to do, I would like to test it. First, let's see if it works. If Trojan works, if I do it from my local Docker before I push it to Kubernetes, but just on my local Docker on my attacker machine, let me check if it works, if it gives me a reverse shell. So here I have my listener, like attacker listener. And let me run this. So let me build container from this image. I will click run. I can also do Docker run, something like this, but let's just click run here. It will be faster. And fingers crossed. Yes. So we have a reverse shell. You can see here the IP address. Let's see if that's the IP address I have. If config.me, yeah, 40, that's the same IP address. So a reverse shell came from this IP address. So yes, I do have reverse shell, but this time to attacker machine only. Okay, and that was the first step. We test, we know that reverse shell is working. So the image we built is working. Now what we need to do, we need to push this image back to registry. And again, if this registry requires authentication, it will be harder, of course, because we need to have credentials as well. In my case, it will be easier because I just need to push without authentication, because I can figure it like without authentication for the sake of time. So I need to push it back to registry. So I say docker push, and then specify the name of my image, and it will be pushed back to the registry. It will take some time. By the way, this time it will not take any time because I already have it in my registry, so probably it will not spend any time on this. If I do it, the access already exists, so I don't need to do anything. So that's why it was quick. And let me quickly check that in the registry I do have the image. So let me type localhost catalog, and yes, we have hello W in the container registry. All right, so now it seems legit, right? So it seems like we do have the container registry that contains image, which is Trojanized. So let's take the next step about our compromising of supply chain. We will make a deployment in Kubernetes. For that, I will go back to legit admin machine. Let's first take a look what kind of containers I have, what kind of pods I have in Kubernetes. I do have some kind of application with voting, database, Redis, worker container, engine. So number of containers, number of pods. In terms of Kubernetes, we call them pods. Let's test if they work. So let's see if they work, if the application works. I will try to test. Let me find out my worker node. So here's my worker node, and I have some kind of, let's type service, kubectl get service. And I do have some, so voting application is 31,000 3 zeros. Yeah, it works. It works. So what I would like to do, I would like to make one more deployment and internally access other applications, because this voting application is published, but it uses also Redis cache. It uses some kind of databases that are not published. So let's see if we can somehow access this internal data, like backend data, by deploying our compromised container. So let's do that. I'm going to type kubectl. Oh, wait a second, I need to configure my listener again. And type this time kubectl apply -f and add my YAML file. So let me just quickly show you my YAML file just to show you what I'm going to deploy. So in Kubernetes, we make deployments in the YAML format, where I need to describe my deployment. And here I say that I'm going to deploy from image in my container registry. That's the image that we pushed before, right? So our Trojanized image. And I would like to publish also that application, which is not very special application, just a simple web page, which will be published on this port. But it doesn't matter. The most important, it must give me the reverse shell. So let's see. Oops, sorry. Let's press enter and cross your fingers. It must give me reverse shell to Kubernetes worker node. I get a reverse shell, and is it the same IP address as we saw before? Yes, that's the same IP address. That's my worker node, and that's the IP address I receive reverse shell from. All right. So now let's take a look. Who am I? ID I'm root in the container, and now let's take a look what we can do in this container. The container itself is not very useful for me. It's just a container. There's nothing special in this container because I know this container. But what I can do, I can try to take a look and find other containers if there is no really appropriate network security. So first, what I would like to do, I would like to configure DNS to make sure that this has a name resolution, public names, and I would like to install some tools on this container. So let's install curl. Shouldn't take long, and maybe a bit longer it will take to install a famous tool called nmap. Oh, come on. That's something that I cannot reconfigure. So other stuff I did, but this one is not really possible. Okay, let's try to install nmap. Was too early? Oh, that's fine. And after this, I will be able to make a full network scan. Of course, full network scan will also take a lot of time, so I will cheat here a bit, and I will use some kind of IP address that we're already aware of, like this one and this port. Or we can scan for all ports, doesn't matter that much, but a single port will be scanned even faster. Let's see. Oops, sorry. I think we already finished. So reverse shell not always give me the nice response. Let's see if so we finished. And now let's try to make a scan. I will type nmap and IP address 10.106.19.78, and the port will be Redis 6379. Also, probably it will not allow me to make a probing, so I will disable pinging, and let's see. So yes, port is open. I can do the same for other machines, for other containers, but let's stick with Redis. All right, so I found that there is a Redis on one of the containers. Of course, in the real world, I need to run the scan on multiple addresses to find out where we have Redis and so forth. But here, for the sake of time, I'm using the IP address that we're already aware of. And now what I would like to do, if I found Redis, I would like to connect to Redis. So let me install Redis tools. I guess we're already done. And let's type here Redis CLI -h, and then IP address of the Redis server 10.106.119.78. Oh, damn it. Space. All right, so let's see if I have access to Redis service. Yeah, looks like I do. Let's see what it's saying me here. Redis version, and so for it. So now I have access to this Redis cache, connected clients, and so for it. All right, and that's how we were able to compromise backend by using the mix of the problems. So like supply chain, then bad network controls, because in that case containers pods need to be separated from each other, like why one application can access another application. But that's what we have by default, and when we follow those defaults, that's what's happened. All right, so I have one more slide and then we go into finish this part of presentation. All right, so you saw one of the problems, and the problem, I mean, it was not really one of the problem. Again, let me go back. So there was like a problem of multiple things at time. So we have improper permission settings, compromise in supply chain, inadequate network controls, and so forth. But what we can do with this, generally speaking, do opposite. So first of all, secure API access. Make sure that your API node is well protected and requires authentication. Then use network segmentation. Honestly, all those things a bit hard to show because Kubernetes is quite universal, and like network segmentation, network can be used. Like we have different network plugins. We can have like Flannel, we can have Calico, and so forth. And the configuration is different. But the general approach, network segmentation. Make sure that like one application cannot access another application, because why my application about like hello world, hello W. Oh, by the way, I didn't really show you, but that's the one that I pushed into what was in the container image. There was a simple application. I think it's like this, hello world. And on purpose, I made this typo just to show that it's really my image. So that's the still application, which was Trojanized. So it still looks legit, but at the same time, it gave me reverse shell. So make sure that one application will not be able to access another application. I mean, if they don't have to, of course, when we have like single application with back end and front end, they need to have some kind of access, but not one application to another application and so forth. Plus, not every component, even in a single application, should have access to all other components. So if you have like a 3-tier application, then web tier doesn't need to have access to DB tier directly. So they have like a middle tier in between and so forth. So store sensitive credentials, store credentials securely. Then use trusted container images. Don't deploy containers from all over the world just without verification. And also, if you are using your own container registry, make sure you configure permissions properly, and ideally also network isolation. So do not allow access from everywhere in the world, and only like from the trusted host. And of course, continuous monitoring. That's what we always recommend to everywhere. So use monitoring to detect some kind of things. Because if one container starts to like port scan in your Kubernetes, it could be detected. And because container normally should not run nmap and so forth. So detect this suspicious activity. It's still better to detect it earlier than have the persistent problem. All right, so that's what I would like to show you about Kubernetes protection. Of course, there are more possible problems, and it's nice to have a long discussion about this, but we're still limited in time, and I guess you also would like to ask some questions, maybe. From OWASP, there are recommendations about containers. So let me just share my screen again. Maybe it will be, let's do it like that. And there is some recommendations from OWASP about container security, like keep host and Docker up to date, not expose Docker and daemon, and so there's quite a kind of long article, and it touched Docker, containers, and so forth. So yes, OWASP has some recommendations. Maybe not the most comprehensive guide in the world, but it does. Okay. So I would say Kubernetes the most popular, and also Kubernetes implemented in the different locations. So maybe Kubernetes in the Azure cloud, Kubernetes in the AWS cloud, Kubernetes in GCP. So that's they made there based on different clouds. But there are other services from providers. For example, if you are working with for example, Azure, they have their own their own container service called Container Apps. Let me just say Container Apps. For example, this Azure Container Apps, which is something in between Kubernetes, like it gives you efficiency of Kubernetes and like simplicity, not really simplicity, but more simple to configure compared to like full Kubernetes. So they're from Docker Swarm. Docker Swarm. So there are a number of them, but again, Kubernetes became like one of the most popular, and one of the reasons many cloud providers support it, and that makes like the even transfer between cloud platforms more transparent and more simple. So Kubernetes is still one of the most well known. Also, by the way, other providers will have the same problem. I mean, maybe different configuration, but they will have, if you push the Trojanized container to another orchestration tool, it will behave similarly. So you saw that I got a reverse shell to Docker and I had a reverse shell to Kubernetes, which works similarly in both platforms. Generally speaking, this specific thing about supply chain when we Trojanize image can work on any platform. So I think I have recordings when I did it in Kubernetes, in Azure Container Instance, somewhere else. So in the same manner, it can work from any platform, because it's just a container image that you normally deploy and gives a reverse shell to the platform. Of course, it depends on your configuration if you can move from this container anywhere else. But that's up to you. Not depend on the platform itself. So what if we disable internet access? That's the good idea, and that's what I mentioned before about the networking. So if you have, it's not only about container, but in general. For example, do you need to have internet access for your container registry, or it must be available only internally? Next question: do you need to have access to your Kubernetes from outside, or maybe those containers work only for your company privately? One more: if some containers need to have access to internet, do you need to have other containers to access to internet, and so forth? So yeah, the smaller attack surface you have, of course, it's always better. And that's the reason why why I'm making all of those demos, to convince you that it's not really about the software itself. Yeah, of course, we sometimes have vulnerabilities in the software. So but it will be fixed. Eventually, it will be fixed. But configuration that you made, it is your responsibility. So that's the reason why I'm showing that stuff. And I saw a statistic somewhere that only 30% of the companies really implement all the best practice, really following best practices, fully following best practices. And so if you have those misconfigurations, this scenario is possible to expose publicly. It depends what your kind of application you have. Of course, API gateway might be a bit more secure, but depends what you're going to publish. I would say API gateway will give a smaller attack surface, but again, it depends what you're publishing. worse. So if some kind of insider has access, so for attacker, let's assume you have a Docker registry available only privately, only inside of your company and not published to the internet. So in that case, for attacker, it will be additional challenge to get into first, and then only after that they will be able to access the registry. But if there is an insider, then insider may have access to internal registry right away. Of course, it depends of your networking. You may not allow connection from. You should allow only connection to your registry only from Kubernetes, not from any kind of workstation internally. But with insider, it could be even worse, because insider already has some kind of trust, already trusted, so they have more access. Honestly, I didn't show anything about like breaking the container and then and so forth. So I didn't from here. I didn't really access the host operating system from here, and most of the time it happens because of some kind of vulnerabilities that usually get fixed. So protection of shared kernel is just like normal protection of operating system, installing software updates, because again, most of the like when you break in a hypervisor and accessing the host operating system is based on the vulnerabilities that normally fixed by the vendors, and so make sure that you install all of the software updates on time and fix vulnerabilities, and of course apply hardening. So network control, principle of least privileges, malware protection, and so forth. Yeah, that's what I've done. So registry. So first I pushed Trojanized image to registry. I did it before just for the sake of time, and then the Kubernetes pulled and deployed the application from this container image, and that container was able to scan and access other pods in Kubernetes. Exactly, that's what we've done. If no more question appeared next minute, I would like to say that thank you very much for your participation today. I hope that was informative, and my primary goal was here to show you that if we keep default, if we don't follow the best practices, if we don't do something that is recommended by the security providers and by vendors, then many things possible. So hardening. Still, we should not only rely on the built-in protection, but also we should take many additional steps. And one of the things about Kubernetes is that Kubernetes requires configuration. You can configure something simple, like install plugins and don't do anything else, or you can make additional configurations and make it much harder. Second option is requires more hassles, but of course become safer. All right, so now it's time. I hope it was informative, and would like to see you next time on other webinars. And thank you very much, and stay safe and keep your Kubernetes and containers safe as well.